All right, chapter 12, the final chapter. This video will be, less than 10 minutes. This is on dilating three-dimensional shapes. Back in chapter 7, we did dilations on two-dimensional shapes. So now we're doing it on three-dimensional shapes. Quite honestly, I should have just lumped this in with chapter 7, but that's all right. So we have three things on a three-dimensional shape that we didn't have on the two-dimensional shape. First, we have the length of one side, right? We have the length. We also have now a surface area, right? The surface area. And we have the volume, right? We have the volume. And these are all going to scale differently. They're not all going to scale linearly like they do on the two-dimensional shapes, right? So if we say we're scaling by k, scale by a factor of k, like that. Well, first we just do, for lengths, they do scale linearly. For lengths, you just do lengths times k, right? And I'm going to put k to the first, and that equals your new length, length prime. For surface area, however, you want to do your surface area times k squared, and that equals your new surface area, right? So this one scales quadratically rather than linearly. And then for volume, it scales cubically, like this. So this is kind of your cheat sheet here, and it goes 1, 2, 3 with your scale, with your exponents on your scale factor. And because the length determines the surface area and the surface area determines the volume, right? Then because the length is length times length, so if you have k to the first times k to the first, that equals k squared, right? And that'll give you one face that you multiply times 6, and it gives you the surface area. So then if we have the surface area times one of the lengths gives us or one of the faces times one of the lengths gives us the volume, right? So that would be k squared times k, and that's equal to k cubed. And that's where all of these values come from, the k squared, and k cubed. Like that. So hopefully that makes sense. And now I'm going to give you one example and then 2 practice problems for this. So I'll keep this right here, and then I'll come off here. If we have a cube like this here, this is our cube. It's a terrible drawing, but if I shorten this up a bit, like that, that's a better cube drawing. If we have a cube like this, and we say one length is 3 units, right? So if we solve for our length equals 3, and then our surface area then would be 3 times 3 is 9, times the 6 sides is 54. So our surface area is 54. And then our volume then would be 9. 3 times 3 times 3 is 27. So this would be volume is 27. And those are our 3 units that we can then plug in here. So let's say we're scaling by a factor of 2. right? We're doubling the size. Well, that would say we have to do, for the length, we just do times 2 to the first, same as times 2, and we get 6 is our new length. Our surface area would be times 2 squared times 4. 54 times 4 is 216. And then here we would do 27 times 2 cubed. 2 cubed is 28. 28, what? 8, I apologize, I don't know what I was thinking. 2 cubed is 8, so 8 times 27 is also 216. And those are our new what do you want to call them, units for this cube if we double it. Right, so let me give you a couple problems here to practice this. All right, okay, first, so if we have a cube with side length 4 and we double it, so if we have a cube here, like that, this should be here. I'm not good at drawing, but if we have a cube of side length 4, and I want you to scale this by a factor of 2, so we're going to double it again, right? Well, first let's find our original numbers, units, right? So first we have the length. The length equals, let me get another color for this. The length is 4. Our surface area equals 4 times 4 times 6. So 4 times 4 is 16. 16 times 6 is 96. Right? So this is 96. And our volume is 4 times 4 is 16, times 4 is 64. Like that. And if we're scaling by a factor of 2, remember we do times 2 times 2 squared times 2 cubed, like that. So first 4 times 2, that equals 8. Let me use the thick side. That equals 8. So 8 is our new length. If we do here, 96 times 2 squared is 4. 96 times 4 is 384. 384. And that is our new surface area. And if we do our volume, 64 times 2 cubed is 8. 64 times 8 equals 512. So 512. And that is our new volume. Like that. So these should be your answers here. Like that. I have one more example for you. Here. If we have a cylinder with radius 1 and height 3, so if we have a cylinder like this with radius 1 and height 3, like that, I want you to scale it by a factor of 4. Where k equals 4. We're scaling by 4. So first our lengths are 3 and 1, right? So our length equals 3 and 1, like that. our volume equals, so we would do pi r squared, right? So pi times 1 squared is just pi. So we do pi times 3, our height, and we get 3 pi. Our volume is 3 pi. And our, I forgot surface area. I apologize. Surface area, and our volume is 3 pi. Now our surface area, if you remember the long formula to solve for surface area equals 2 pi, what is it? 4 pi r or something. 4 pi r plus, or 4 pi r squared plus 2 pi r height, like that. This is how you solve for the surface area. Let me write that a bit larger. 4 pi r squared plus 2 pi r height. This could also be pi dh, however you want to do it. And that's how you solve for the surface area. So if we plug everything in here, we get 4 pi times 1 squared is 1. So we get 4 pi, 4 pi plus 2 pi 1 height. So the r cancels again, and we get height equals 3. 3 times 2 is 6, plus 6 pi, like that. We could just add these together, and we get 10 pi. Right? Let me check my math here. 10 pi. Yep. Okay. I think that's right. Right, because if we plug in 4 pi 1 squared plus 2 pi 1 3, second insert, times 3, and we do 10 pi. Yep. So our answer is 10 pi. For the surface area, 10 pi. So let me erase this word here. I wrote it incorrectly. I did the math incorrectly on here. I don't think I accounted for the bottom circle here on the cylinder, but doesn't matter. So now we have our initial values, and we can just multiply by 4 up here. So this equals 3 times 4 is 12. So we get 3 times 4 is 12, and 1 times 4 is 4. So that's your answer for the new lengths. For the new surface area, we do 4 squared is 16. 10 times 16 is 160 pi. 160 pi is your new answer for the surface area. And for the volume, 3 times 4 is 12. So we get 12 pi on this one. On that. And these are your new, your new, whatever you want to call them. I've been fumbling through this. I probably should have looked up what the proper term for that is before I started filming, but your new lengths and volume surface area is 12 and 4. 12 for the height, 4 for the radius, 160 pi, and 12 pi for the volume. And that wraps up not just chapter 12, but this entire geometry series exactly on July 31st. So I'll go put this in the YouTube and send out a message to everybody that it's finished. I guess technically 1 day before the due date is still the due date. And thank you for watching this series on math, and Lucy Elliott for suggesting it.